Good day, everyone. Today I am going to give example regarding with the MOSFET. So here there is the circuit of the MOSFET, yeah, shown in this figure, and this is the D, yeah, terminal. So this is the symbol of the MOSFET. And then this is D, this is source, and this is G. And then here is a grounding. Then in this point, the voltage is 2.54. Yeah, in this point in D, yeah, VD is 0.54, and at the bottom, so the voltage here is 2.544. Then we have a resistance, yeah, and D terminal, yeah, or as a RD. There is the resistance in the S terminal is a RS. So the question is to find the RD and find RD and RS, yeah, where the ID current here is 0.4 milliampere. Yeah. And given that the threshold voltage is 0.74, and then the mu n, mobility of electron times oxide of capacitance, the oxide capacitance. So this is 100 microampere per square voltage. And then the dimension of the transistor is L equal 1 micrometer, and W, the weight is 32 micrometer. And then given the ID, with the ID equal to Kn over 2 VGS minus Vt, VGS, this is VGS, yeah, minus Vt square, and Kn equal mu n Cox W over L. Yeah. So the question is to find what is the RS and RD. So in this case, the RD, yeah, can be determined the drop voltage in RD and the current flow in this resistance, yeah, 0.4 milliampere. This is as a ID. This is ID equal 0.4 milliampere. So the RD here, yeah, RD equal, yeah, the drop voltage, the RD, drop voltage RD, VRD, yeah, over current ID. Yeah. So this is we know that the RD is a VRD minus over ID. So VRD is a drop voltage in the RD, that is the 2.5 minus 0.5. Yeah. So this is the drop of voltage. So we can calculate here that the uh, RD is equal VRD over ID. Yeah, equal the drop voltage is the 2.5 minus VD is a 0.5, yeah, over 0.4 milli. Yeah. So equal to 5 kilo ohm. So this is the first answer for the RD. Now, what is the RS? Yeah. So the RS here, RS equal, yeah, of course, this is we can also same as a RD, yeah, similar RS equal V RS, yeah, over ID, yeah, because the current, the ID is the current flow in the RD and the RS is same. So this is the current from D to S. Yeah, D to S is a 0.4 milliampere. So now, what is the VRS? Yeah, yeah, ID already we know 0.4. Yeah, so this is the uh, VRS. VRS here. Yeah, and the drop voltage in the resistance RS, yeah, is the Vs minus 2.5. So the drop voltage here. So we should find the V in the S terminal here. So we can call as a Vs, yeah, Vs here. So this is the we have a Vs. Yeah. So how can we find the Vs? Since we have a VGS here. Yeah, VGS. We have a VGS. Yeah. So the we can have a VGS, yeah, equal VG minus Vs. And then from this uh, Vg and Vs, we know that a G terminal is grounded. G terminal is grounded, meaning that the Vg equal 0. So Vgs equal 0 minus Vs. So then we can have the Vs equal minus Vgs. So from where we the VGS we can find VGS we can uh, find from this equation. Yeah, ID equal Kn minus over 2 VGS minus VT square. Yeah, so we know that ID already known, and Kn we can calculate, yeah, with this equation, and then the VT is already given 0.7 volt. Yeah, VT is the threshold voltage, the requirement of the voltage of the VGS, yeah, to uh, create the channel region. Okay, so we can continue. What is the RS? The RS equal RS, yeah, equal VRS over ID, and then equal uh, 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 VRS is a VS minus 2.5. Yeah, so this is a 2.5. Yeah, VRS here is VS uh, minus 2.5. Yeah. So this is the VRS, and then ID is a 0.4 milli. Yeah, and then uh, uh, again the Vs, yeah, Vs equal minus Vgs, yeah, just now is given, and then the uh, where, yeah, this is where Vg equal 0, because the terminal G is grounded, so this is easy to find that the Vg is a 0. And then VGS we can find from the ID equal Kn over 2 uh, VGS minus VT square. And then we have Kn, yeah, from the previous uh, equation, the Kn equal mu n the COXW over N equal, this is 100 micro, and then the multiplied W is 32 micro over 1 micro. So this is we can have we can remove the micro, and then we can get the uh, Kn equals 3200 micro. Okay, and then from the ID here, so we can solve the equation. ID equal 0.4 milli 3200 micro over 2. And then we have a VGS minus 0.7 square. Then we can solve this equation. We can have a further 0.4 milli equal 1600 micro VGS minus 0.7 square. Again, then we can have this is simply we have a 0.25 equal VGS minus V. This is VTS is 0.7, 0.7 square. So then we can have the equation ABC equation. ABC equation. So we can further solve this one. 0.25 equal VGS square plus 2. This is ABC equation. I think you know already. VGS plus 0.49. So C B square. So minus 7 square, so 0.49. So we can have this ABC's equation is VGS square minus 1.4 VGS plus 0.24 equal 0. So then we can solve the using the ABC equation. This we can have VGS equal ABC equation. We have a minus minus B. Remember square root of B square minus 4AC over 2A. Then we can have here VGS VGS 1 and 2 equal positive 1.4 plus minus square root of minus 1 4 square minus 4 multiply 1 multiply 0.24. Then over 2A, A is 1. Okay, then we can have here 1.4 plus minus 1 over 2. Okay, so then we can have VGS 1 equal C here 2.4 over 2 equal 1.2, and then VGS 2 equal so this is 1.4 minus 1 so this is 0.4 over 2, so this is 0.2. So we have a value of a VGS 1.2 and 2.2. This is 4. So which one this is the applicable for this problem? We know that the VGS should be more than threshold voltage. So we know that the uh, 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 VGS should be more than threshold voltage. We know that threshold voltage equal 0.74. So then in this case, this is the correct one. So this is the correct. This is not correct. So 1.2 watt. So the VGS equal 1.24. Then we can have here the Vs equal minus VGS. Minus VGS means minus 1.24. So this is the answer for the Vs. Yeah. Then we know here that the Rs, Rs the dependence of the uh, Vs minus or plus 2.5 over 4 uh, 0.4 milli. So we have then we have Rs equal uh, Vs plus 2.5 over uh, 0.4 milli. Yeah. So then we have Vs. What is the Vs? Vs minus 1.2. So this is equal minus 1.2 plus 2.5 over 0.4 milli. Yeah. So then we can have here uh, yeah, equal 3.25 kilo ohm. So that we can now we can solve the RD is a 5 kilo ohm, and then the RS is a 3.25 kilo ohm. Yeah, this is the solve the problem. Okay, thank you for your attention.